Today we're going to be working on notes 8 and talking about equations that are proportions, basically. And so first we're going to talk about ratio and what a ratio is, and then what a proportion is and how do we solve it. So a ratio just means that we're talking about a relationship between two quantities. Okay, this is normally expressed as a quotient. Okay, of one divided by the other. Okay, so for example, if I had a box and it contained 6 red marbles and 4 blue marbles, then I could say the ratio of red to blue marbles is 6 to 4. Or sometimes we see ratios written like this, 6 to 4. Or it's written as a fraction, 6 to 4. And for all of these, I can reduce. So if the ratio from red to blue marbles is 6 to 4, we could write that as 3 to 2, or here 3 to 2, or here 3 to 2. Okay, so a ratio is just a relationship between two numbers, okay, two quantities. When we have a proportion, that means that we have two equivalent ratios. So we have a ratio equal to another ratio, okay, and we call that a proportion. In our proportion, we can also write it like this. A to B equals C to D. In our proportion, we have our B and C here are what we call the means of the proportion. And A and D are what we call the extremes. And if I look at it in my fraction setup here, A and D, you'll notice, are across from each other, and C and B are across from each other. So I have the means and the extremes of my proportion. The way that we typically solve a proportion is using cross multiplication. So if I have A over B equals C over D, the product, meaning multiplication, of the means is equal to the product of the extremes. Okay, that's a property of proportions, meaning if I multiply A times D, it would be equal to multiplying my means together, B times C. Okay, so when we use cross multiplication, 9 times out of 10 to solve our proportions. So we have a few examples here. So here I have one ratio equal to another, cross multiplying here. So here's my extremes, here's my means. Now what we need to be careful about is the distributive property and making sure we're multiplying the entire value here. So 6 times -1, that's going to give me -6. That will be equal to 3 times x plus 8. Okay, that entire numerator needs to get multiplied by 3, which means we'll need to distribute. And I get -6 equals 3x plus 24, and I subtract 24. And 3x equals -30, and x equals -10. Okay, cross multiplication. Same idea on the second one. So multiplying x plus 10 and 4. So I'll have 4 times all of that numerator, x plus 10. is equal to 3 times that entire numerator, 2x subtract 12. Okay, notice it's no longer a ratio, right? And it's no longer a number over a number. Okay, so when I cross multiply, it becomes multiplication equal to another set of multiplication, a product equal to a product. Okay. Distributing on both sides gives me 4x plus 40 equals 6x subtract 36. I'm gonna subtract 4x. So now I'm just solving, just like we have been solving in our equations. And I'm gonna add 36 to both sides, which gives me 2x equals 76. And I divide by 2, and x equals 34, 38, 76 divided by 2, 3, 6, 16, 8, 38. Solving for x on my next proportion. So now my variable terms in the denominator, no big deal. Okay, cross multiplying, I have 8 times all of x minus 1 and 3 times all of x plus 2. Distributing the 8 and distributing the 3, 8x subtract 8 equals 3x plus 6. Subtracting the 3x equals 5x subtract 8 equals 6. Adding 8 over, 5x equals 14. And x equals 14/5, leaving that as an improper fraction. Okay. So now what I want you to do is pause the video. If you flip the page over, you'll see that there are 4 proportions on the back side of these notes, and you're going to try A, B, C, and D on your own, and then start the video back up again and see how you did. Okay, so here you see the answers for examples A through D. You should check your own work, make sure you were distributing through and multiplying all the way through on examples C and D. Now we're going to look at some application problems with proportions that we'll just have to set up the equation first, and then we're solving the same way where we're cross multiplying. So it says a bag of blue and yellow candies. The ratio of blue candies to yellow candies is 3 to 5. If the bag contains 60 yellow candies, how many blue candies are there? So first of all, this question right here, this tells me what my variable is. Okay, so my variable is how many blue candies there are. X is blue candies. And I can set up a proportion because I know that the ratio is 3 to 5. And I know that it's, even if I have 60 candies in the bag, it's going to be this ratio from blue to yellow. And this is going blue to yellow. So blue to yellow, 3 is blue, 5 is yellow. So this is blue, that is yellow. So when I set up my proportion, this 60 yellow should be in the denominator to match this initial ratio, 3 to 5, blue to yellow, blue to yellow. Now what I don't know is how many blue there are in this bag. Okay, so that's blue. Blue to yellow equals blue to yellow, equal ratios gives me a proportion. And now I'm just going to cross multiply 5 times x, giving me 5x equals 3 times 60, gives me 180, and I divide by 5. And 180 divided by 5, 5 goes into 18 3 times, leaves me with 30, so it gives me 36 what? Okay, so since we have a word problem, we should answer with words if that makes sense. If we're trying to find blue candies, we shouldn't just say they're 36, we should say 36 blue candies. Okay, there's my answer. The distance, so a lot of times we see ratio and proportion on maps and scale factors on maps or diagrams. The distance between two cities on a map is 600 miles. On a certain wall map, this is represented with a length of 2.4 feet. On the same wall map, how many feet would be between Memphis and Philadelphia, two cities that are actually 1,000 miles apart? Okay, so there's two ways that I could set this up. So I can either set it up going from the first city, so saying, okay, so 600, in my mind, I would want to do this. 600 miles is represented by 2.4 feet. So then 1,000 miles would be represented by how many feet on the map. So that's one way to set up the equation. Okay, that this ratio from the miles between the first city and the miles between the second city should match the feet of the map for the first city to the feet of the map for the second city. You could also do like 600 to 2.4, so put the first city on one ratio. It should be the same ratio, the same conversion for the second city. So there's a couple ways you can set this up. Cross multiplying gives me 600x equals, so when I multiply by 1,000, that's going to move my decimal place 1, 2, 3. So it's going to give me 2,400. Dividing by 600, that's going to cancel out my zeros, is going to give me 4 feet is the distance between those two cities on that same map. Okay. This one's a little bit of a tricky one because there's two different units here at the beginning. So it says a room. So if I think about a rectangular room where I have length and width, the room is 16 feet 8 inches long. So 16 feet 8 inches long. The ratio from length to width is 4 to 5. So from length to, that's kind of tricky because the length is actually shorter than the width, but my diagram's not the best. So from length to width is 4 to 5. Okay, length to width is 4 to 5. Length to width. I can set up a proportion here where over here I also have length to width, and I know the length and I want to find the width. Now I can't put in like two different units here, 16 feet 8 inches. So what I need to do is I need to convert the 16 feet 8 inches to either all feet, so a decimal value using feet, or all inches. So I'm going to go all inches where I say, okay, well, 16 feet, that's 192 inches plus the 8 inches that are on there. That's going to give me 200 inches across my length. So my length is 200 inches. We don't know the width of the room, right? That last question tells me what my variable is. Cross multiplying gives me 4x equals 1,000. Divide by 4, and 1,000 divided by 4 gives me 250. 250 what? 250 inches, okay? So units would be the same here. And so 250 inches, if I want to convert that down to feet, well, let's see here. So 250 inches, if I divide that by 12, okay, to make that into feet. So if I do 250 divided by 12, that tells me I have 20 feet, and what would be left for my inches? So 20 feet is 20 feet is going to be 240 inches. I have 250 inches around the width of my room, so that leaves me with 10 inches. So 250 inches is 20 feet, 10 inches. So I'm just converting it back so my units match what I started with here. And my width of my room would be 20 feet, 10 inches. Okay, I want you to try to set up this one on your own. So read through that problem about the fish and try to set up a proportion and solve, and then continue the video. Okay, so it says they tagged 500 fish in Grand Bay on October 12th. At a later date, they found 7 tagged in a sample of 700. So we want to estimate the total number of fish. So I'm going to go, there's 7 out of 700, right? So there were 7 tagged out of 700, okay? We initially tagged, right? So here we have tagged and the total. Okay, so they collected a sample of 700 fish, only 7 were tagged. In Grand Bay in total, they tagged 500. So in the numerator, I'm going to put 500 were tagged out of how many fish are in Grand Bay. Okay, and it's going to be an estimate. And so cross multiplying here, we get 7x equals, let's see, 350,000. Okay, multiplying 700 times 500. And then I'm going to divide that by 7 on both sides. So 35 divided by 7 is going to give me 5, and I'm going to keep those zeros there. Gives me an estimate, it says to the nearest 100, that's funny, of 50,000 fish living in Grand Bay, right? Okay, so tonight you will have some homework. Actually, let me look real quick since I'm ahead of where we actually are. Tonight what you're going to have is homework, but after you watch the percent video. So we kind of started proportion while we were in the middle of absolute value. So you won't see these proportions pop up until we're on the quiz 2 review. And so just to show you, like here we have equations and it's just kind of mixed in, right? So here's a proportion on the quiz review. And then on the back page, again, you have equations and it's just kind of mixed in. So what you're going to see when you get to this quiz review is you're going to see all sorts of concepts that we've talked about so far put together. So here's an equation, here's an absolute value equation, here's an inequality, and oh look, here's a proportion. Okay, so you're really applying this skill kind of mixed in with other equations that we've seen so far. Okay, all right. Can you hear my cat talking to you in the background?